I said it's a lot. Like, yeah, definitely more than it because that's what they call it. Actually, it's like nothing. Something though. It might not have to do directly with me, but something. Someone. Is out. Wait, was it usually fall? I feel like it's usually like that. Bit of me. I just really want to talk. If you're is that so hard to be full? Is that so hard? But still, this looks like that would be good. If you told me 5 minutes, she was like, I'll do that. Never mind. I'm talking to this other dude. I don't want XYZ. Okay.
Okay, so guys, let's get started. Today we have a lecture and so your tests are graded and a midterm and they opened, so you can review them. And if you have any questions, you can make us, you can write me with a grade request for specific, because it was auto-graded, but of course, not all the test cases were in the auto-grader system. Your practical is not graded yet, so I hope I will finish it today. But practical, almost, I believe the majority will have 100% for practical, unless your code didn't run on the test system. So who knows how to access, well, you know, the practical on the server from your machine. So are you interested to know how to access the server machines from your machines? So you can actually run also Python on the server instead of on your machine. So, okay, I will show you because yeah, we had one student who didn't submit the assignment on Gradescope, but it was saved on his machine. I mean, in the lab machines are connected to the server, so it was saved on the server, and we uploaded from server his submission on his machine and then on Gradescope without going into lab. So, let's share. So if you go on the course page under CS department, and there is CS department in infrastructure. Here is information about the servers. So if you want to access so if you want to access the server machine, you should open terminal and type this secure shell command, your name, and after your name before it, you should type one of these machines, so or GLaDOS or Quack. So I will show you. So if you open the terminal, then you can type SSH and your name. For example, mine is AMS before it. And after it, any of these two machines, for example, GLaDOS, .cs.rit.edu. When you type your username and the machine name, it will invite you to type the password, and in terminal you won't see what you're typing. So don't so you will just type password, but the cursor won't be moving. And if you're okay, it looks like I made a mistake in my password. Okay, if the password is correct, then you will log in on the server. So now, currently, I'm actually on the server machine, not on my machine. And here you can type ls, and it will print the folders under your account on the server machine. So you will have PyCharm projects. This directory actually where your projects were stored. You also have the public HTML folder. In this folder, you can create your index file, and it will be your web page. So, for example, my web page is here. I can list directory public. Oh, by the way, instead of typing the entire path, you can just start typing and press tab, and it will continue this name. So for example, here I have index HTML file, and you can access just using web browser. For example, mine is AMS CS and so on. So you will have access to your, you can create your web page here. Sorry? Oh, which system? You mean the server? I don't know. They're typically updated every summer, or in winter after the term is ended. But in summer, all I believe. Oh, do you mean when they will remove your information? So I just want to say that this is additional infrastructure that you can use to create, for example, your home blog page, or, for example, yeah, or for example, you can change directory to your PyCharm project and list. So in this maybe you will find there a folder which you called midterm one. Then you can go into this folder and okay, it looks that my folder is empty. So we can go back, change directory and two dots. It will return you on one level on the previous level. Let's see the other folder. Okay, it looks like my folders are empty because I didn't work on the machine, but your folder should contain your file. So, yeah, if you type ls, will you see something?
Okay, picture.
Yeah, and also this Python project. If you type ls and you can tab, you can press tab, it will config. Yeah. Okay.
Oh,
You will find your practical there. I didn't have it. Huh? No.
Are you cool? Are you cool?
Exam prep or it doesn't mean like ours is it's not here. It's like, but there's actually no such file. Oh, and that I don't because there is no such file.
Yeah, I just said you were.
Even though it's
So.
And then just a picture of that one.
I know. Okay, really?
Just, I think it was talking about,
So.
how we can access our.
And this is why yeah, and
That's the
okay. Oh, maybe because I don't know. So if you want to, so could you find your practical on the machine? So now if I don't know, maybe can I ask maybe you to demonstrate how to actually I can do this on my machine, how to download this file on your machine. So for example, let's see. I have here some files like test file py. You can run this file, just type in Python and the file name. Okay, I don't remember what is inside my file. Oh, okay. In my file, I don't have any output, so if I print something, so then it will run my file, but it runs the file on the server machine, not on your machine. So if you will, the only problem that if you run file with Turtle, it will give you an error because the terminal can't plot the graphical interface for Turtle.
There's an application that can render the terminal, like a screen.
Okay.
It's in research.
Okay.
Let's use that remote.
Okay. Yeah. Okay. So, but I don't believe that beginning from now you will use Turtle. So there are two ways to download the file from this machine or from your machine to the server. The one way is the hard way, just to do this from the command line. So you can, for example, I open another terminal, which in which I'm on my machine. So here is my machine. And I want to download the file from the server machine. So first of all, I need to know the path on the server machine. So to know the path, you can type pwd, and you will see the path to this folder. I will just copy paste this path. And on my machine, you can do security copy. See, okay, first of all, let's list. Oh, wait a second. Okay, on my machine, it's a Windows machine. On Windows machine, there are a little bit different comments. If you want to list the files, the comment is dir directory. So because the server machine uses Linux, and this laptop uses Windows. So the comments are a little bit different, but still I can. So for example, I have here documents, downloads. So let's say I want to upload file and downloads. So the comment is security copy SCP, and then again your name, the name of the server machine, ms gladys.csrat.edu, and then colon, and insert the pathway to your file on the server machine. Here, oh, pwd.
Specify the file.
Yeah, do you mean and file name? Yeah, and now file name. So here I have, for example, test file py, test file.py, and now you indicate the directory on your machine. So for example, in my case, I want to upload to downloads. So I start typing down and then tab. So if you press tab and it continues the name, it means that it sees this folder. Okay, and then when I press enter, it connects to the server. The server asks for the password. And after, if your password was correct, you will see the progress of the downloading. And now in my folder, in my folder documents or downloads. Here is this file. So if you want to upload the file from your machine to the server, you can do the same, but from when you're on the server. The easy way to do this is to use, for example, FileZilla. So you can download another app and then connect to the server just using this app, and then you can what's called transport your files just as an usual file manager.
How do you get all those op-eds? Like when you put the drop down.
Yeah, so if you want to connect, you should type here the host, and the host is this server name, like Gladys dot cs rhc dot edu, then your username and password, and port, I believe it's 22. Oh, actually it says 22, and connect, and it will connect you to the server. Okay, so this is just for your information how you can access the files on the server machine, how you can work actually remotely from your machines on the server. And I think the most exciting thing, you can create the web page, and the web page will be running on the server. So if you create this in the folder public HTML. Okay, that's it for you, just information. So now I exit from the server machine and I'm on my machine, and I will close this. Okay, so today the topic of this week is testing and debugging, and we will start with exceptions. You have seen a lot of exceptions when you wrote incorrect code. So let's talk about these exceptions. So why they're called exceptions? Because these are exceptional cases. For example, I want to create a variable, a string of A's, and the size of this string is 10 power 16. Then I get an error, a memory error. If I want to import a module that doesn't exist, I will get an error, module not found. If I want to add string and integer, I will get a type error. So there are many other errors. So if you want to, guys, if you don't want to listen, please leave the room, okay? Because there is a lot of noise from you. I mean, just leave the room, and nobody holds you here. I don't take attention. So if you want to somehow what's called process these exceptions instead of just exiting from the code, there are these comments, try, except. So try will try to do something, and if this work, then it will just continue running the code. But if there is an error, you will get the exception. And then there are different ways. So the one way is just to use except and colon. And for example, print something here. The other way to check what type of the exception. Was it a type error? Was it a memory error? So you can check for the exception type or for several types. And as in elif, you can have several exceptions. But also you can read the exception as a new variable, like exception as a variable name. And then you can do something with this exception. So let's do an example. Okay, so, oh, by the way, today we will use also PyTest. But okay, we'll go to this later. Okay. So, for example, let's try to divide by 0. And let's check the exception. Except. So, and in exception, for example, we can print something. Print observe the math. So when when the code will run this, instead of exiting from your code with error, it will just print this information. So this is how you can handle the exceptions. Let's create a variable. I don't know why, but maybe we want to store this exception and use it later. So let's create an empty variable. I'm not sure if var is the built-in name. I don't know. Just in case I will type variable. None. We just initialize this variable, and then we will do the same, try except. But in exception, I will create a variable that will read this exception. So except as, and an arbitrary name, for example, E as the first character of exception. And here we can assign this value to our variable equal to E. So, oh, what I typed, oh, it should be exception. Okay, let's do again. Try division exception. And I will store this variable. So now, even though there is division by 0, you don't see any error. So your code continues working, but the error information is stored in variable. We can print this variable. And we will see the information that we would see without this try except. Also, you can print the type of this variable. And the type of this exception is zero division error. As I mentioned above, there are many different error types. So this specific type is zero division error. So then you can somehow, I don't know, use this information. Okay, let's go back to slides. These exceptions are the elements of the larger class, which is called base exception. And if you type base exception dot and this hidden method subclasses, you will see, it will list all the subclasses. Exceptions, exception, generator exit, keyboard interrupt when you type Control C, and system exit. So as you understand, what we see when we run our code, these are all elements of this subclass exception. Because if you will do key interrupt, it will just stop running your code, and you should work with these exceptions differently. Okay, so these are examples. These are some types of errors. Assertion error, you will see it later when some of you guys used assert for the previous in lab, like when we asked to test. I saw some of you used assert, and the result of the function equals to something. So if the result, if this statement is false, then you will get assertion error. Import error, when we'll try to import the module which doesn't exist. Name error. For example, your variable begins with the number. You remember it's prohibited. Type error, memory error, index error. You want to access array with larger index, for example, great index. Key error, you will see this when we will talk about dictionaries in 2 weeks. What's happened? Is overheated, maybe. Maybe some of you just log in into server and somehow switched off the project after I showed you how to do that. It's weird.
You should teach it.
Well, maybe if you know the password to the this account, maybe you can, yeah, you can do that. So if your interpreter encounters unforeseen error, you will get value error. So value error is just any error which is not from the other errors. And here is example when you can get value error. for example, I want to split the string by empty string. Typically, we split a string by space or comma and so on. But if you want to split a string by empty string, it will give you a value error. And here is the description about all the error types.
Are the errors strings? When you store errors, it's stored as a string.
No, it's a class. Everything in Python is class.
Also, errors are
Yes. And they have their methods. For example, when I showed you print, I didn't show you. Okay, I will show you now. Print variable dot args, arguments, for example, args. Here I access to the attributes of the class. And here is the string which is stored in this variable.
I see.
Mhm. Okay. See you. You're welcome. Answer, please. Okay. So let's see. Okay, that's it about the error types. Now let's talk about the test cases. I don't know, the previous group was just sleeping when we were talking about testing their code. Maybe it's very annoying topic. So let's think about why we should actually test our code. Can you think about some examples when the testing of the code can be useful? I mean, of course, we can write one test case like, yeah.
If there's like multiple things that build off each other, you have to make sure.
Or like many functions, and the second function uses the output of the previous function. Yeah, that's a good idea. So, what will you test in this case? For example,
Like a true or false output or.
but which output are you expecting?
Or like, if you expect a certain output, then you test for it, if you get it, then we're.
Oh, so just one test?
Yes. I mean, you could have multiple.
Can you think about tests that will test all possible inputs for the previous function? So, I said that we can use tests. For example, if we have stacked functions and we want to be sure that the output from the first function is correct, so we can use this as input to the second function. But can you elaborate it a little bit this example so that it works for any input, arbitrary input in the first function, not for just specific one? Because if we test our function just for one case, maybe it will work for this case, but it will fail for another case. So how to make this like broader?
That's.
Well, you can think about the output of your functions. For example, if your function should output a string, you can test if it outputs a string type instead of integer, for example. And then it will, this test on the type will work for arbitrary. Does that make sense?
Yeah.
Okay, so we don't want, well, actually we do write for you guys in our test system, we write just particular test cases, but it's a bad practice because, by the way, what is the goal of the tests?
Find bugs.
Yes, to find bugs. So, so if your write just 3, 5, 10, 100 test cases, maybe your code will work for these test cases, but won't work for billion of other cases. So that's why I'm saying that what we are doing in your homework submissions, like just several test cases, it's actually not a good practice, but it's a good starting point. So, okay, the goal of test cases is to find the bugs in your code. There are other reasons why the tests could be useful. First, to understand if it was your idea incorrect or it was an error in your implementation in the code. So this is one reason to write the test of your code. Another, if you think about like several nested functions, you can decompose your code into smaller pieces. So when you think about testing these nested functions, you're thinking about decomposing which every unit of your code is doing. And the most maybe important reason for the test cases is to make other people easier understand what your code is doing. Because, for example, for the final project, we will provide your test cases, and just looking at the test cases, you will understand what your function should actually do. Like if my function wants to reverse the string, and we provide test case, the string and reverse string, without actually looking at the code, you will understand what this function should do. So these test cases somehow will document your code. But it's important to understand that any tests, even very nice tests won't prevent your code from bugs, because it's impossible maybe to observe all possible test cases. Okay. Now let's talk about different levels of testing. So if you want to test only one function, it's called unit test. You test just one unit. If you want to test several functions, then it's called integration test. It will test a couple of functions or more, several functions. Finally, if you want to test the entire system or entire project, which maybe consists of several files, it's called system test or end-to-end test. And finally, when your program will be in production and the user will click on the link and the user will get an error, this link doesn't exist, it's called the user test. So, and this is the less desired bug in your code if the user will see the error. So we will work with these first two layers, and if you want to read about like other layers and how to test them, there is also a link. And as I said, there are other classifications, like end-to-end is the same as system testing. Stress test, can you guess just from the name what does mean stress test?
Like performance,
Yes,
like the how optimized it is.
yes. For example, if your server will work with many connections, or if, for example, the input will lead to overflow or division by zero. It's also the stress test. And okay, now I hope I convinced you that testing your code is useful. Now let's talk about how to write the tests, actually. So, instead of just writing one or two tests for the code, how to write a good test. So first of all, if you write just few test cases, you will maybe unforesee multiple other errors in your code. So that's why it's not a good idea. And as we were talking before with Alex about the testing, for example, for the data type, then we take care of any input. It's called property-based. We test the property of the input or output of our code. Oh, hi. The person who got 100 on the midterm. Okay. Maybe you can, I don't know, maybe you can help us and tell how to use Vim in sometime, Vim editor. Because if you want to work with command line, then it's useful also to be able to edit your code also on the server. Okay, so yeah, let's find some time and you can show guys how to do this. Because I'm using Nano, but Vim is much better for editing. So you can teach me as well. So, well, it's rare when we want to edit code on the server, but sometimes we want to do some edits. Okay, and so if we take care about the because we were talking about midterm, I want to show you also one submission that actually I fell in love with this submission. I will show this function. I was grading 100 something block, and when I saw this implementation, it was kind of reward for me because it was very unexpected solution. I just want to share with you. So here's the function, and the task was to write the recursive implementation, and here is the answer, just one line. So I really like this solution. So this is the base case, and else is, oh, sorry, this is the recursive case, and else is the base case. So very, very elegant solution. Okay, let's go back to testing. So if we have the test that covers many possible inputs, then we can generate randomly, or it means automatically create thousands of test cases and do testing. And there are several methods that we can use. By the way, will we do the break or not? What do you think? We can do a break after I will show you PyTest, or we can continue and without break. But well, feel free to leave the room whenever you need the bathroom or whatever. So if we don't do break, we'll finish early. So, yeah, sorry, no break. Yeah, so if you need a break, just feel free to leave for several minutes. So the built-in test for Python is a unit test, but because it uses classes and we don't formally cover classes in CS1, we won't use that. PyTest is typically people prefer to use PyTest. There is also dog test and assert. So assert is the less desired test method, but it can be useful. So, for example, if you create a new version of your code, a new version, I don't know, of Windows or iOS, you want maybe at least you expect that it will perform exactly the same the old tasks that the tasks that the old version performed correctly. So in this case, you can use assert, and for example, you will compare the output of the old version and the output of the new version. So in this case, assert will work. But typically, well, if you use assert just for individual test cases, again, it works for the class environment, but not maybe for the real projects. So, docstring, doc test, you can just type the test case in docstring. So this is the docstring, and here I type the expected input with the function name and expected output. And if I run this docstring, it's not really interesting, so maybe I will just skip coding this. It will. So if you run doc test mode, it will substitute these tests in your function, and you will see the results if the tests were passed or failed. So this is called docs test, and you should import doc test for this reason. The most popular program for testing is called PyTest, but it's not distributed with default Python. If you want to, I actually installed this with the previous group. So if you want to, so originally on my computer, I typed PyTest version, and I've got this information that PyTest is not recognized. So if you want to install a new module for Python, you can type this pip3. You can type pip, but for Python 3, it's typically we use pip3. Install U for updated version and the name of the module. So you can install, actually I can type with U, but I have this installed, so I believe I will just get, yeah, it says requirements already satisfied, but still it's tried to install it. So how this PyTest works? When you type, so yeah, if you need to see the syntax, if you pip3 install and the package that you want to install for Python. So when you run PyTest, and your file name. It will read your file name, and any function that contains this word test, it can be just a part of the name of the function. If it sees this subword test, it will run this function. So let's try to create. How much time do we have? Actually, we have time. Eden, don't you mind to create a file in Vim, and then we will run this file for testing, or we want to do this next time? How do you feel?
Next time.
Okay, then I will do this in PyCharm instead of. Okay. So, but next time we will have a lot of to cover. We'll do sorting, searching lists. So maybe not in the next, maybe some we will find time for Vim presentation. I don't believe next time we will have time. It will be busy week. Okay. Let's for the example, I will create a new project. A new project. Week 6. Oh, 5. And let's create a function, for example, that reverses a string. Define a string s. So how to reverse a string? How to reverse a string? Okay, this is one way to do the negative slicing. But what if I want to create an empty string? Another way, new string will be empty string, and then for character in string, I will concatenate characters, new string. So, and here's the question: should I concatenate like my current variable with current character, or I should concatenate the character with current string? So which of these lines will actually reverse the string? The second one. Why? So if in the beginning it's empty string, it was just random guess.
What? No.
Okay. So can you explain why? So
Because,
we start from empty string. What do it?
well, because you're going through it, so it just go through S string. So S first. Then
So
the
it will
T gets
read.
added.
It will read the first character.
Yeah, the first character, and then it gets added to the front. The second character, then it gets added to the front. The third character. Gets added to
Yes.
the front.
So we kind of append the characters, but every time from the left. From left. Yeah, from left. And then it will reverse it. I just wanted to show this example because there was question on the substitution trace for string. Oh, you learned this from the midterm, okay. Okay, and here's our function. And now we can write the test function, define, as I said, PyTest will run any function that contains this subword test. So test reverse. So in test function, we will call the testing function. So result, we can create a variable result of reverse. And here we can, for now, just create one test, like hello, and assert, but this assert will be a part of PyTest. So this is a good assert. It won't give you an error. Assert if the result gives the correct output, OLEH. So now, where's terminal? So it's important that we run PyTest in the folder which we want to test. So now I can see that I'm in correct folder. So I can just type PyTest and the file name. And the file name is main. Or I can just type PyTest and it will go through all the files in this folder. Let's see.
What do you mean we're in the wrong file? We're in the wrong folder.
Oh, so for example, in this folder week 605, we have several files. Then, if I just type PyTest, I don't think it will work now. Let's see, because there is also another comment if which version of Python we want to use. Okay, it says no test run. Let's try to type Python M. Python, and I believe for most of you it should be Python 3 M. So the version of Python, because on one machine you can have different versions of Python, Python 8, Python 13, and so on. Let's see if it works. Huh?
Python was not.
Yeah, try Python 3.
No, I didn't.
Oh, it's weird. And okay, for some reason it didn't run my file. Let's type just file name, which is main. Okay, and now you can see that it one test passed because in my file there was just one test. Let's now a little bit change, and I will just write the incorrect test. If I do incorrect test, then you will see this output, failures. And what is good about PyTest is in assertion, you will just get an error. But with PyTest, it actually will return the value that resulted in the error. So that's why people typically use PyTest. Because here you can see which test it didn't pass. So it substitutes the variable from the test example. Okay, now let's talk about the general process. So everything is on slides. If you want to repeat, you can just go through the slides. Oh, by the way, you remember we mentioned earlier, maybe several weeks ago, decorators. PyTest has also decorator where you can pass multiple test cases. So like one test case is empty string case, and then this value expected will substitute all these test cases. Now let's talk about like general process, how to create a good test, how to write the broken function, and it's called TDD, or test-driven development. So maybe some of you have heard about this before. Did somebody hear about test-driven development before? So, okay, because in other groups there were guys who knew about this. So the idea of test-driven development is that first you create a stub function. The function that returns, for example, none, just empty function. And you create a test that doesn't test anything, like placeholders. I believe I should. Okay, we'll see this in a few slides. Then you start filling in your function. It's called refactor. And for example, you add one working case in your function, and you test this case with your test. If it fails, it means you should go back and work on your function. If it passes, you should create a new test that your function won't pass. And then you will go back and correct your function. If this function passes the new test, that's fine, you create another test. If it doesn't pass the new test, you should, be careful, you can create a wrong test also, and you will check your function if it works correctly on a wrong test. Yeah.
How many times can I do this?
Oh, how many times? I don't have an answer. I believe it all depends on the scale. If it's unit test or if it's like it's called the next level in when we test several units, or if it's the system test. So it all depends, I believe, on the complexity. So let's write our last function for today, which will be the testing using this test-driven development. And we will see how it works in practice. So the course work page propose to test this function, this Collat's conjecture, which says that if you take arbitrary integer number, and if it's even, we divide by 2, if it's odd, we multiply by 3 and add 1, and we continue this process, continue until we reach 1. So this conjecture says that continuing this process with arbitrary integer, we always will return 1. And it's not proven, that's why it's called conjecture. But it was tested, I looked at Wikipedia, up to 10 power 20 from 1 to 10 power 20 integers. So it works for this first. What's the number? 10 power 10 is Google. 10 power 20, I even don't know the number for this. Google of Googles. So it was tested for this, but we don't know. Maybe it will be wrong for larger numbers. And this is actually an interesting example how mathematical proofs can use computational powers. Several years ago, the Gödel's hypothesis about prime numbers was proved by a computer, because for large numbers there was proof, analytical, mathematical proof, but for all smaller numbers they just ran the machine and they didn't get errors, and this is how they proved for all integers. Do you know another example of mathematical problems which are solved? Actually, they're solving during this time. Many people are and institutes are working on these problems because there is a prize, like thousand, I don't know, or $1 million. Do you know this problem? Which
I forgot what the hearing was, but it was like, it
about
was like a line.
yeah, but which
Is it the non-trivial zeros?
well, it's close. Yes, answer here actually is about integers, but more specific. These are which numbers are used in cryptography? Yes,
Prime numbers?
prime numbers. Yes. So this is the problem, to find the next prime number. And because it's used in cryptography, it's very important. And that's why people are running the kind of, do you know, some algorithms to find prime numbers. Like if there's Euclid algorithm. Well, the easiest way just to try next integer and find its divisors, but it's very inefficient because there are so many combinations for divisors of a large number. So this is another example where computers are used to find or solve mathematical problems. So let's take a look at this example. If we start, for example, with number 5. So the 5 is odd. So how we should transform 5 according to this procedure?
3 times 5 once,
And how much will be 3 times 5?
or 50.
You added 1, but it's correct. So what we'll do next, according to this procedure, it's even. How much we'll get? The next value, 8. What we're doing next? Yep. What we're doing next? 2. And finally, we will get 1. So we proved the Collatz conjecture for one number, for 5. Now we can prove this for 6. Do you want to prove this for 6? Or you believe Wikipedia that it's proven for 10 power 20? Okay. Now let's write the function that implements this procedure, and then we will test this function. So any ideas how to write the function that will test arbitrary integer that after this procedure it's either returns 1 or smaller than 1? Any ideas how to write this function? Iteratively, recursively. Maybe recursively is the easiest one because we always apply the same procedure on the next step. So what will be our base case when we will stop this calculation? When n, well, if we believe in this conjecture, then if n is 1, but if we check this conjecture, then when n is equal or smaller, this will be our base case. And okay, let's call this. Clear all drawings. New file. Let's call it collats. And we create the function, define function. Let's call it also collats. I hope he doesn't mind that we use his last name with lowercase c. Collats. And it takes an integer, let's say n. Oh, I didn't mention in your practical, you have seen such things like this int. So in Python, you can indicate the expected data type. The interpreter, if you will use as input string, interpreter won't give an error. So these types are only for users. That's so you could see in practical these errors and error and type. So base case, if n is smaller or equal 1, we will return what we will return? 1 or n? We will return n because we are testing if our number is actually 1 or smaller. So we will return n. If how to check that n is even? Mod 2 equals 0. The reminder of the division by 2 remainder, not remainder, remainder of division by 2 is 0. Then we divide this number by 2. Return collats of n. And because I want to work with integers, I will use integer division. Otherwise, I had to cast int of n divided by 2. Because we don't have other cases, I will use just else. Return collats of 3 times n plus 1. Okay, the function that we will test is ready. Now we should write a test case. So can you think about any test cases for this hypothesis? This is the test on the type. But if we want to check the value, what is the expected output of the function? The expected output is 1. So actually our test will cover all integers. Any inputs should result in 1. Okay, so let's for now I will write just the step. Oh, sorry, I didn't. I had to start with step function, just collapse, return and a none. But I have just written the entire function. Okay. We can do a step function for test. Define test collapse and result is collapse applied to, let's say, 5. And if we don't use any return statement, then it won't return anything. So it's our step function. If we want to test, we should write assert. So I have written just for one test case, then we will elaborate this for random inputs. Let's try to run the test, the PyTest. Now I want to test collapse. What? Wait a second. Why? Co- what's going on? PyTest. For some reason, it doesn't see my file. Oh, PyTest. Okay, maybe it was my spelling. Why doesn't see PyTest? Or maybe I should save the file.
Then I just.
Oh, wait a second. For some reason, it's in the folder. Oh, thank you. Okay, let's move this to yes. Okay, now it's in my root, and okay. PyTest collapse. Okay, one test passed. Finally, if we want to create multiple tests, we can import random. From random import rand int, and we can do a for loop in range, for example, 10. We can do for range in million. And test that for arbitrary integer, the result still will be 1. Let's see if our test will work. I believe it won't. Yeah, it failed in one test. And here is this actual values which didn't pass the test. So any guesses why our tests failed?
So you didn't define a third thing. That has to be no. If it's below 1, that has to be. It's like undefined.
Yes, but it's easier because I am. Oh, wait a second. I didn't actually use random numbers. Wait a second. Let's do just for arbitrary. Oh, the answer is that my range begins from 0.
Yeah.
But I had to write range from 1. But I want to do random numbers, so let's do, instead of I, just rand int. Rand int. And rand int for how many? From 0 to 5, for example. If our random generator, okay, 1 failed. Um, oh, maybe it needs 2. No, wait a second.
Yeah, it's 0 to
It says missing positional argument. Okay. Um, where's this error? It's hard to find. Should it be, should I use from 0 to 5 or I should use a tuple like this? Ran, okay, extra parenthesis. So, do you remember how to use randint? It looks I messed up with randint. Let's see. And int. It takes start and stop. Hmm. I don't know, let's see. Okay, now it works. Okay, it seems that for an int we should indicate the starting index and also. So but it failed. It failed, and the problem, I don't know if you understand what is the problem, that my rand int takes random numbers from 0 to 5. So I have 0 in some random numbers. If I correct this from 1 to 5, then it will generate 10 random numbers, but all tests will be passed. Okay, that's it about testing, and finally debugging. So there is this bug symbol on the top, and here's debugger. So debugger will help you to trace your code step by step. You can use the, okay, it's hard to see here because I don't have any prints in this function, in this code. Just type print lots of 5. So we can put this marker where the interpreter will pause. Okay, let's see if it works. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, Okay, so it entered this function. Let's see. Aha. And now it entered the randint module. If you want to skip this module, you can press step out. And after step out, okay, we went to some other module, right? Okay. Mhm. Okay, what's going on? Well, at least you should see some variables. Oh, wait a second, it's this file. Hmm, I don't know. Maybe we should pause here. Oh, okay. So if I make this stop point in the function, at least you will see the name values, and also here debugger will provide the variable value. So if we do next step, it will go to the if, but because n is 5, it will go to the next line, and in the next line, it calls our function recursively. So let's do next step. In the next step, it entered the new version of our function and the new value of n, which is 3 times 5 plus 1. So yeah, so this is how debugger works. Interesting thing is you can change the variable name during interpretation. So for example, I can open console and type here n equals 100, for example. Or let's do n equals 7, for example. Now, if I open debugger, you will see the new variable value, 7. So you can change the variable names in this debug mode on the fly. If you need this, I don't know, maybe sometimes we need that. And then it will proceed with this value from now. Okay, so I think that's it about debugger. And if you want to read more, there is information on the course web page. It explains every button of this debugger. Now let's take a test and call it a day. I'm sorry, maybe it's a little bit annoying because for now you don't feel like that you need to test your simple functions. But at least you learned about exceptions and error types. Oh, why it's switching off and on? So the password is test123. So let's open. Oh, testing123. Yep. So yeah, so next week, uh, you submit your lab, but the week after we will have a break, the fall break, and the next homework submission will be due 2 weeks instead of due just 1 week. And you won't have classes and labs after 1 week, just one lecture, but no recitations, no labs. Next week is still normal schedule. The week after there is 2 days break. And we will shift the gears mostly to algorithms now, not to the Python syntaxes, but to the algorithms like sorting, so. And no turtle anymore.